Or this is the second part of chapter 18. It's covering pages 350 to 357. We're going to cover the second law of thermodynamics. All right, so the second law of thermodynamics, remember thermodynamics is the study of how you can use heat and energy to get mechanical energy. And this one, like law number 1 is about the conservation of energy. Law number 2 has to do with the way heat travels from hot to cold. So when you're using a heat engine, which is going to be a mechanical engine that takes heat and uses it to do work. So that's just the general term is called a heat engine. And there are 2 main parts of your heat engine. You've got your reservoir, where you've got your heat that you're taking it. You convert that into work, and then you expel that energy into the low temperature reservoir. So you've got a hot temperature and a low temperature. And the low temperature one is called the sink. So we're going to call the hot one the reservoir, and then we're going to call the cold one the sink. So you take heat from the reservoir, use it to do work, and then you dump it into the sink. So conservation of energy, there's no such thing as a 100% efficient machine. If there were, it kind of defies some laws, because there's some heat that is lost due to friction, mainly due to friction. But there's no such thing as a 100% efficient machine, and I'll show you why. The difference between the temperatures, whether you're in your hot and your cold reservoirs, your reservoir and your sink, the difference between them, how hot it is and how cold it is going to change your efficiency. So you want them to be very different temperatures, because if they're just a little bit different, temperature Kelvin-wise, then you're not going to have a very efficient machine. And you want to have the most efficient machine you can, but you can't have a perfect machine, and I'll show you why in 1 second. Let's look at the efficiency of a heat engine. There's a nice little equation that goes with it. You're going to take your hot and you're going to subtract your cold. So remember I said on the previous slide that the efficiency is going to increase when the greater the difference between the temperatures of your hot and your cold reservoirs. And then you divide it by your hot, keeping in mind that we will be using the Kelvin scale whenever we do this. So let's say our hot one is 3000 Kelvin. And let's say our cold one is 100 Kelvin. All right, so we would take those and we would subtract that and we would divide it by 3000. Well, you can see that when you subtract that 100, your top fraction here is going to be smaller than your bottom fraction. So when we divide it, we're going to get a decimal. All right, so we've got 3000 minus 100 and then divided by 3000. We would have an efficiency of 96.6, so I'm just going to say 97%. Okay? 0.966, so I'm going to say 97%. Now, how could we get that all the way up to 100? Well, the only way that we would get a 100 is if our top and our bottom are the same number, because a number divided by itself is going to give us 1. So when we turn that into a percent, it's going to be 100%. So how could we get this top number to be exactly the same as the bottom number? We would have to divide, we'd have to have a cold reservoir of 0 Kelvin. So if we had a 3000 Kelvin hot and we had a 0 Kelvin cold, and we divide that by 3000, 3000 minus 0 is 3000. 3000 divided by 3000 is 1, or 100%. So the only way that you could have a 100% efficient heat engine, is if the sink were 0 Kelvin, and nothing's ever gotten to 0 Kelvin. We can't even get close to it. So there's no way it could ever happen. So there's no efficient machine, so just keep that in mind. To sum it up, first law of thermodynamics, energy cannot be created or destroyed. That's basically the law of conservation of energy. Second law of thermodynamics is that energy is going to deteriorate into less useful forms as it is used. So like the heat engine shows, is that you may start with really good hot stuff, but it's going to deteriorate and it's going to become less useful the more it's used. And the word that identifies this is called entropy. So entropy is often the second law of thermodynamics is called the law of entropy, and it's because entropy is going to be disorder. Things go from order to disorder all the time. So the law of entropy is just a measure of the disorder in a system. And so you've got your law of conservation of energy, which is kind of your first law of thermodynamics. Second law is like the law of entropy, and it's based on that you're going from hot to cold, and along the way, you're going to lose a little. So go ahead and click on the link to do the homework, and I will see you in class.